Hi everyone, myself Bhumika. I am Annegiri from Sri Venkateshwara College of Engineering, pursuing my first year engineering in the Department of Information Science and Engineering. Today's subject is Introduction to Mechanical Engineering and the topic is electric and hybrid vehicles. Let us know more about electric vehicles and hybrid vehicles. An electric vehicle is an automobile that is propelled by one or more electric motors using electrical energy stored in energy storage device. Electric vehicles are increasingly becoming a part of modern life. Its tremendous fuel economy, eco-friendliness and smooth driving feel have appealed to many consumers. Electric vehicles are propelled by electric motors and uses electrical energy stored in batteries. Unlike vehicles with combustion engines, electric vehicles do not produce exhaust gases during operations. There are two types of electric vehicles: battery electric vehicles and hybrid electric vehicles. Components of electric vehicles: EVs use the electricity saved in the battery to cycle the motor and generate the power necessary for driving. This is the biggest difference to internal combustion vehicles, in which the engine uses fossil fuel to generate that power. EVs carry several components for electric power: motor, battery, onboard charger, and electric power control unit. All are essential components to achieve the conversion of the battery's electricity into the kinetic force that drives the EV forward. Motor. The motor converts electric energy into kinetic energy that moves the wheels. The advantage of using the motor instead of an engine is numerous. First, the noise and the vibration we typically associate with cars are minimized. Reducer. The reducer is a kind of transmission that serves to effectively convey the motor's power to the wheel, but it carries the special name reducer for a reason. The motor has a far higher RPM than that of an internal combustion engine. The reducer must always reduce the RPM to an appropriate level. Battery. The battery stores electrical energy and is the equivalent of a fuel tank in an internal combustion engine. The maximum driving distance of an EV is often determined by the battery capacity. The higher the capacity, the higher the driving distance. Onboard charger. The onboard charger is used to convert alternating current from slow chargers or portable chargers used on home outlets into direct current. This may take the OBC look similar to the traditional inverter, but they differ in function. The OBC is for charging and the inverter is for acceleration or deceleration. The OBC is not needed in fast charging since fast chargers already supply the electricity in direct current. Electric Power Control Unit. The Electric Power Control Unit is an efficient integration of nearly all devices that control the flow of electric power in the vehicle. It consists of the inverter, the low voltage DC-DC converter, and the vehicle control unit. Inverter. The inverter converts the battery's DC into AC, which then is used to control the motor speed. Low voltage DC-DC converter. The LDC converts the high voltage electricity from the EV's high voltage battery into low voltage and supplies it to the vehicle's various electronic systems. Vehicle control unit. It controls all the vehicle's power control mechanisms, including the motor control, regenerative braking control, ARC load management, and power supply for the electronic systems. Advantages of electric vehicles: it reduces air pollution. It means that it is eco friendly. Because electric vehicles do not utilize fuel for combustion, there are no emissions or gas exhaust. Vehicles that run on fossil fuels contribute significantly to hazardous gas accumulation in the environment. Switching to an EV instantly eliminates toxic pollution such as nitrogen oxides, carbon monoxide, and hydrocarbons, provided the charging is from an appropriate source. Battery for our energy security. Almost 85% of India's oil needs are transport related. Therefore, rapid adoption of electric vehicles would help reduce India's crude oil import. Less noise and smoother motion. Driving an electric car is significantly smoother because they lack fast moving elements, they are quieter and produce less noise. Cost effective. Electricity is far less expensive than fuels such as gasoline and diesel, which are subject to regular price increases. When solar electricity is utilized at home, battery recharging is cost effective, less running cost per kilometer. Low maintenance. Because electric cars have fewer moving components, wear and tear is reduced when compared to traditional auto parts. Repairs are also simpler and less expensive than combustion engines. Almost 100% of these batteries can be recycled, which keeps old batteries from becoming a disposal problem. Downsides of electric vehicles: high initial cost. Electric vehicles continue to be quite expensive. The purchase price of electric cars does tend to be higher than a petrol or diesel engine version of the same car. Charging station limitations. People who need to travel long distance are concerned about finding adequate charging stations in the middle of the journey, which are not always accessible. Recharging takes time. Unlike conventional automobiles, which require only a few minutes to replenish their gas tanks, charging an electric vehicle takes many hours. Limited options. Currently, there are not many electric car models to pick from in terms of appearance, style, or customized variations. Less driving range. When compared to conventional automobiles, electric vehicles have a shorter driving range. Electric cars can be convenient for short distance travel but are inconvenient for long distance travels. There are possibilities of fire hazards. Hybrid vehicles. The term hybrid vehicles in general usage refers to vehicles with two or three different types of source delivering power to the wheels for propulsion. The most common hybrid vehicles have an IC engine and one or more electric machines for vehicle propulsion. The IC engines can be used to generate electric energy on board to power the machine. The main components of hybrid vehicles are given below: gasoline engine, electric motor, fuel tank, transmission, batteries, and generator. Gasoline engine. The hybrid vehicle still has a gasoline engine. This remains to be the main power source of the vehicle. Electric motor. This is the feature that makes the hybrid vehicle particularly special. The electric motor has the ability to accelerate the vehicle by taking power from the battery. Fuel tank. You will still have a fuel tank to store your gasoline like in a conventional vehicle. Due to the advanced technology in hybrid cars, the fuel won't need to be used as much. You will have better fuel efficiency and produce fewer emissions on a result. Transmission. Most hybrid vehicles will still use a conventional transmission that you would find in a regular gasoline car. However, there are new transmissions being built specifically for certain hybrid cars. Batteries. The batteries are what power the electric motor of a hybrid car. Not only that, but the batteries can actually take power back from the electric motor too. This is one way their lifespan can be preserved. Generator. If you have a series hybrid vehicle, they have a generator which gets powered by the gasoline engine. The generator can then generate power for the electric motor and help recharge the battery. It is basically a way of converting gasoline into the electrical energy for the motor and battery. Advantages of hybrid vehicles: environmentally friendly. One of the biggest advantages of a hybrid car over a gasoline powered car is that it runs cleaner and has better gas mileage, which makes it environmentally friendly. A hybrid vehicle runs on a twin powered engine that cuts fuel consumption and conserves energy. Financial benefits. Hybrid cars are supported by many credits and incentives that help to make them affordable. Less dependence on fossil fuels. A hybrid car is much cleaner and requires less fuel to run, which means fewer emissions and less dependence on fossil fuels. This in turn also helps to reduce the price of gasoline in the domestic market. Regenerative braking system. Each time you apply the brake while driving a hybrid vehicle, it helps you recharge your battery a little. An internal mechanism kicks in that captures the energy released and uses it to charge the battery, which in turn eliminates the amount of time and need for stopping to recharge the battery periodically. Built from light material. Hybrid vehicles are made up of lighter materials, which means less energy is required to run them. The engine is also smaller and lighter, which also saves much energy. Disadvantages of hybrid vehicles. Less power. Hybrid cars have twin powered engines. The gasoline engine, which is the primary source of power, is much smaller as compared to what you get in single engine powered cars. While the electric motor is of low power, the combined power of both is often less than that of a gas powered engine. Can be expensive. Hybrid cars are comparatively more expensive than regular petrol cars. Poorer handling. A hybrid car houses a poorer handling. A hybrid car houses a gasoline powered engine, a lighter electric engine, and a pack of powerful batteries. This adds weight and eats up the extra space in the car. Extra weight results in fuel inefficiency, and manufacturers cut down weight, which has resulted in motor and battery downsizing and less support in the suspension and body. Higher maintenance cost. The presence of a dual engine and continuous improvement in technology makes it difficult for mechanics to repair the car, and the cost of maintenance is also much higher. It is also difficult to make a mechanic with such expertise. Accident from high voltage in batteries. In the event of an accident, the high voltage present inside the batteries may be dangerous. Battery replacement is pricey. Battery replacement in hybrid vehicles is currently rare. However, if a battery needs to be replaced, it can get pricey. Conclusion. As the world continues to transition towards a low carbon transportation sector, electric vehicles and hybrid vehicles will play a critical role. We can expect to see increased adoption. Electric vehicles and hybrid vehicles will become increasingly mainstream, with many countries setting targets for electrification. Improved infrastructure. Charging infrastructure will expand, making it easier for consumers to own and operate electric vehicles. Continued innovation. Advances in technology will continue to improve the performance, range, and efficiency of electric vehicles and hybrid vehicles. Thank you for watching the video.